Now, we can rewrite this. Let's take, here we have a W2L2 term over here, S prime, okay? Let's assume that beta, let's go back to our assumption, beta is equal to 1 over 1 plus R. Okay, so I'm going to replace this by 1 over 1 plus R, okay? So now I have S prime over 1 plus R, S prime over 1 plus R. I'm going to bring that to the other side, and I'm going to get on this side S prime over 1 plus R times 1 over gamma minus 1 times X2 plus L2 W2 is equal to what? Is equal to S prime over, no, is equal to S prime over 1 plus R times, no, let me get this right. It's equal to G prime of H plus S prime over 1 plus R minus W2. Okay? That's what the condition turned out to be. All right. Now you say, what does that condition mean? Well, the way to understand what that condition means is the following. Suppose you chose H to simply, not to maximize expected discounted utility, but to maximize expected discounted wealth. So what we're going to maximize, okay, what we're going to maximize is the following. We're going to maximize W, and that's going to be equal to, by definition, full wealth. Let's say W1 over beta S W2 minus G of H. So we're going to choose H to maximize net full wealth. Okay. So if you're simply interested in getting as much expected wealth as possible, not worrying about in terms of utility, that's what you'd be trying to do. And if we do that, what's the first order conditions? Well, first order conditions, let's say we have H. H is our only variable here. W is fixed, W1 and W2 is given. The first order condition is what? It's beta S prime times W2 is equal to G prime of H. Right? In concavity with G double prime negative, right? That's, remember we mentioned, that would be perfectly good maximization first order condition. Now, what does it mean? What does it mean? Well, anybody. Eric, what does it mean?
I mean, so the G prime of H is the marginal cost you pay now. And then,
Well, yeah, you only, that's,
yeah, I mean, that's your expenditure on goods and health now, and then what you're getting out of that is the chance that you marginal increase in living.
well, you get some wealth. I mean, what it means literally, if that's what you're saying, you know, by having a higher probability of living, you pick up the expected gain in the wage rate, right? So that's what you're getting. That's your full wage. All right, that's one thing what it means. Yeah, I mean, that's reading off each term and saying what that means. I'm trying to get at something a little deeper than that, and maybe I didn't make myself clear what it means. Go back to the utility maximizing condition over here, right? Right here. 1 over gamma minus 1. When will that condition be the same as this condition? Remember, beta is equal to 1 over 1 plus R.
When gamma is 1.
When gamma is 1. So, that's it. That's an important implication. It really hasn't been recognized that much in the health literature. It's implicit, obviously. What it implies, if gamma equals 1, it implies max V equivalent to max W. And the reason for that is, well, if gamma is equal to 1, its constant returns to scale, really doesn't matter as long as you can pull more time into leisure out of the market segment. It really doesn't matter if you consume more in one period or you consume it broken down by a couple of periods, on the assumption that beta is equal to 1 over 1 plus r, which we use to derive it. Doesn't really matter. So if that's the case, might as well just maximize expected wealth. So under those conditions, all you're doing is self-protecting. You're maximizing, I'm calling maximizing expected discounted wealth self-protection. Okay. But we know that's not the whole problem. Okay. Because we assume in general gamma is less than 1, strict concavity. Right? So we have strict concavity, then what do we know? Well, we know that this side here is positive, right? Because 1 over gamma is greater than 1, so that's positive. Okay? And so that would say that G prime H is then greater than S prime over 1 plus R W2, right? Turned out it's right, what I wrote down. And what does that mean? What does that mean? Well, Eric, you would say, well, it means that the marginal cost is greater than the discounted value of the wage rate, right? It does mean that. But what does it mean more than that?
You're spending less on health.
But 8G is concave, is convex.
G is convex.
Yeah. Increasing cost of wait a minute. Good question. Let me make sure. Yeah, G is convex. That's the cost, so it's a convex cost function. Absolutely, G is convex. So what does it mean? You're spending more.
You're spending more than
because you're picking up an additional benefit. You're picking up this difference between marginal and average utility, which is what gamma less than 1 means. You're picking up that extra benefit. Picking up that extra benefit. And so you're going to go further. So the optimization that we see is a combination, with gamma strictly less than 1, is a combination of the self-protection. If gamma is close to 1, that's pretty much all you have. And if gamma is a lot away from 1, then a lot of what you have is the traditional emphasis in the value life literature, the difference between marginal and average utility. Right? The concavity of the utility function. Okay? Everybody follow that? You follow?
Yeah.
Okay. Why is it happening?
Because you have diminishing returns in each period on moving some of your consumption over to another.
On utility, you have diminishing return.
Right. Exactly.
So what you can get in terms of a better utility stream counts for a lot.
Exactly.
That counts for a lot. Even though you know your marginal utilities are going to be equal in both periods,
Right.
in equilibrium.